All right, so just to recap, we are under Google Classroom. We have clicked on the Matter Lesson 1 textbook pages. We have made a full copy for ourselves. I'm about to send my personal link to all of you. So on your screens, if you're not here today, you're just going to be watching the recording. But this is for my kids who are in class. And this should come up on your screen. That way, you even if you can't see what's happening here on my screen, you should be able to see it on yours. So I'm about to send out. All right, that should be coming up on everyone's screens. Please let me know. Is that coming up on your screen? Okay, so now whatever I'm doing up here on the board, you're also going to be doing, okay? So, all right. Hopefully this is recording the board. We'll find out. This is my first experiment. All right, so Matter textbook pages. Read the textbook pages on the following slides. Complete the questions on each of the pages. Emerson, are you with me? Yeah. Okay. You may use the textbooks on the shelves by the windows if you prefer, but do not write in the textbook. So the purple ones are yours if you're one of those people who likes to have an actual textbook, Matthew, in front of you. The purple ones would be yours, but do not write in them. So if what I'm doing up here is not making sense, you can grab a textbook, okay? Is everybody good? Yeah? Okay. So I'm actually going to open up my copy on here too, just in case. I have a feeling it's not recording that. I think it's recording this, which means, yeah, I think it's just recording. So if I start here, let's see, if I start clicking around on this, let me see, if I start typing something, I want to see if you guys can see it. I'm going to type something on that first page. So let's see if you can see what I'm doing. Can you guys see that on your page? So when I do this, are you looking at like my copy that you have? Can you see what I'm doing? Okay, what did I type? Excellent. Okay, so we're going to move on to slide number 2. Uh-huh. Oh, cool. All right, so then we are working with 2. That is excellent. All right, so I'm going to move on to slide number 2. It's not changing up here, though. Like, I'm on slide number 2 now on my, so it may not come up there. We'll see. So I'm going to zoom in a little bit, and then I'm going to read to you. So you can clamshell for a minute while I read. I know it's not going to zoom in for you, but I'm going to read to you, and then you can relax for a minute while I read, okay? So the first thing we're going to talk about are physical properties. Whether you have a pure substance such as gold or a mixture such as seawater, how it behaves and interacts with other substances depends on its properties. A physical property is a characteristic that can be observed without changing the matter into another type of matter. So nobody should be looking at their screens or typing right now. We should have clamshell. For example, gold will melt at 1,064 degrees Celsius, and it will boil at 2,856 degrees Celsius. So it's melting and boiling, but is that physical or chemical, people? Physical. It is an excellent conductor, meaning that electricity moves through it very easily. And gold also has a high luster, another word for shininess, and a distinctive color. All of these characteristics are physical properties. They can be observed without changing the gold into something else. So now we can take a look at our activity. You can go ahead and open up, and we're looking at the questions on this textbook page. The first one we're looking at is the one with the fish. It says, if iron is exposed to air and water, it can rust. I'm sorry, I'm on the wrong page right now, aren't I? Up here. Oxygen is a substance that dissolves in water. Fish absorb oxygen from the water, and when dissolved oxygen levels are low, it can be hard for organisms to survive. Is this chemical or physical?
Physical, because the never changes chemically. It's always oxygen.
So we know that this is a physical change. The oxygen in the water is a physical change. How can you tell that the oxygen hasn't turned into anything else? Can you observe something? Talk to your table. What can you observe about oxygen so you know that it hasn't changed into anything else? You might have to turn around, Maddie, because your person's gone.
You just type the answer.
Well, I'm getting ready to type it, and it should be coming up on your screen as well. So the answer is that the oxygen dissolves in the water, but it is still oxygen. You can observe, and what can you see that shows that it's still oxygen? Bubbles, right? Okay. So that should be on your copy. That's on your screen that I sent to you. It's also up here.
But it's like not on our.
No, you need to type yours from the one that I sent to you. So, and if you're watching the video, you're obviously watching what's on they can see this on their screen. They know that they need to type this. So if you're watching the video, which meant you were absent on the day we did this, you are also typing on your screen. Okay. Now, when we look at the other question, it's talking about the palm tree. It shows the palm tree. It says water and carbon dioxide in the leaves of the coconut palm tree are converted to oxygen and sugar thanks to the energy provided by the sun. So we started with water and carbon dioxide, and we ended up with oxygen and sugar. Is that a chemical or a physical change? Chemical. As a matter of fact, what's that chemical process called? Where plants turn... Photosynthesis is a chemical reaction. That's good. I'm glad y'all remember that. So here's the answer. Oop. It didn't want to bring up my text box. There we go. Okay, so two substances are changed to two other substances, and that is chemical. Okay? All right, so now we're going to move on to slide number 3. Are there any questions about the chemical versus physical so far? Are we good? Okay, so we're moving on to slide number 3. Okay, and now you get to clamshell again because I get to read to you a little bit. Okay? So everybody should be clamshelled. Nobody should be typing on their computer. If you need to catch up, you will. That's what the notes are for. But we need a clamshell right now. Thank you. Okay, so chemical properties. Other properties can only be observed by combining or breaking apart substances. These are chemical properties, characteristics that describe something's ability to become something else. For example, if you inject carbon dioxide gas into liquid water, some of the water will react with the carbon dioxide to produce carbonic acid, which, by the way, is not as bad as it sounds. This ability to react is a chemical property of water. Likewise, the ability of carbon dioxide to combine with water and become carbonic acid is also a chemical property. So we're going to look at the images in figure 2 and read their captions. The images and captions will help you determine whether chemical or physical properties are being described. So go ahead and look at your screen. And the first one shows a piece of metal. And it says, if iron is exposed to air and water, it can rust. So what kind of property is that, everybody? Okay, it's chemical. And how do we know that it's chemical? Yeah, it is a form of oxidation. So it's chemical because remember, it's the iron. We're going to assume that it's iron. The iron becomes a new substance after reacting with air and water. And what is that new substance? Everybody, what's that new substance? What happened to it? It rusted. Okay, so everybody understand that that is a chemical property. We took iron and we changed it into rust. Totally different. Looks different, has a different chemical makeup. We're going to go back up to this part where it says reading check. And the question here, it's asking you to infer. Flammability is a measure of how easily something burns. Is this a physical or chemical property? And explain using an example. So flammability is how easy something catches on fire. Would that be physical or chemical? That's a physical, right? So it's a chemical property because if you burn something, you're going to change it into something else. I'm sorry, my brain went a little mushy this morning. So remember when fireworks are burning, you remember that example? It's changing into something else. What do you smell when you smell fireworks? Sulfur. It's like rotten eggs, right? That's because you're taking like a gunpowder type substance and lighting it on fire, and it gives off that sulfur like smoke. Yeah, it's not a nice smell usually. It's like rotten eggs, or if you smell well water, it has a lot of sulfur in it. So something being able to burn, or the flammability, is a chemical property. Okay? Because when substances burn, they're reacting with oxygen to become something else. Can you give me an example of something like that? I mean, I kind of just gave you one with the fireworks. Can you give me a different one? Reagan, can you give me a different one? If you burn a piece of paper, that's going to become ashes, right? Which is a totally different thing. Tatiana?
Not Coca-Cola, coal.
Okay, if you burn coal, we probably have more experience with charcoal than we do actual coal, but yeah, it's the same concept. Firewood, wood of any kind, right? So our example would be burning wood, right? That's our example. Okay? Because you're taking the wood of the tree and you're turning it into something entirely different with the ashes. Any questions about that? Any questions about that? Okay. All right. So we are going to actually stop there for today. That's part 1 of what